Bye, Dinah. What? Okay, all right, here we go. So we've actually done three conic sections so far. We've done circles. We did that first quarter. Okay, circles were easy. Then we did parabolas. Those seem a little bit more difficult. And now we did ellipses just the other day, correct? So we are to the last one, which is hyperbolas. Okay, and what is a hyperbola? Hyperbola is the set of all points whose distance from two foci have a constant difference. How is that different from ellipses? Sum. This is a difference. So I'm going to just show you a little bit of what that looks like. If I have a hyperbola like so, this is what a hyperbola looks like, okay? Actually kind of seen a little bit of these before. And you have a focus point that sits there and a focus point that sits there. Here's the idea. You pick a point. Whoa. Oh, that was pretty bad. Should have been more like that. There we go. Call this D1 and D2. And then we'll pick a point, say, here. And we'll go there and there. We'll call this D3 and D4. It turns out that D2 minus D1 is equal to D4 minus D3. So they have a constant difference. And so that makes their equation very similar. The equation for a horizontal hyperbola is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. Does that look familiar? Yeah, it looks like an ellipse, right? Except minus. So, how do we make a hyperbola? First of all, the center is at HK. And then you make a box. The box is not part of the graph. You just make it. Trust me, it'll help you. I took this class over the summer many years ago, and I remember trying to work my way through hyperbolas, and I was frustrated. And I thought the easiest way to come up with the dimensions in the graph was to make a box. If you got a different way, you go ahead. I like this idea. For the box, how many units do you think we're going to go in the x direction? A. How many units do you think we're going to go in the y direction? Exactly. So I'm going to make a box. Where this dimension is A and this dimension is B. The vertices of the hyperbola are like the points where it starts. If x is positive, then it's horizontal. If y is positive, then it's vertical. So these vertices, they sit on the side of the box, like this. So my vertices, from this center, I move A units out and A units back. A units to the right, A units to the left. So the vertices are H plus or minus A, K. We good with that? The transverse axis is the distance between the two vertices. Can somebody tell me the distance between the two vertices? 2a. In order to graph the hyperbola, I need the asymptotes. This is why the box is so great. The asymptotes go through the center and the vertices of the box. Have you seen asymptotes before? Yeah, you have. Asymptotes are the imaginary lines that the graph approaches, but really doesn't touch as it extends towards infinity. So now that I have that box and the vertices, I can make the graph. The graph starts there, and it kind of goes out towards the asymptotes. Starts here, goes out towards the asymptotes. That's my beautiful graph. In order to write an equation for the asymptotes are a line. What two things do you need to write an equation for a line? A slope and a point, right? You need a point on the line. What point do both of these lines go through? The center, right? What do we call the center? We call it HK. That's the point that it passes through. Slope of the lines. Look at the box. What's the rise of the box? B. What's the run of the box? A. So plus or minus B over A. The foci, they sit here. There's two of them. Anybody want to guess how many units from the center they sit? C. Which means we need to be able to figure out C. We have an equation for C. It's A squared plus B squared is equal to C squared. See that? Okay. So the foci are going to be H plus or minus C, then a K value. You're going to add or subtract it to the X value. All right, before we do the next notes, let's just try one so you can get it, understand what the heck we're doing. Let's start with the center. We'll label the vertices. We're going to label the length of the transverse axis. Good morning. We are going to label the, let's see, what else do we have? Length of transverse axis. Asymptotes. And then foci. What's that? Are you making fun of my math terms?
No, I feel like foci is like the name of like a germ.
A germ?
The little guy who shows up on like the Mucinex.
Oh.
The little green guy.
Okay. So for those watching, Morgan Amfinson just said that the germ guy on the Mucinex commercial should be named foci. Is anybody else confused? Like, it's okay.
A great name.
It would be a great name. You're right. I agree. I agree.
Off topic, but great name.
Thank you for that.
Yeah.
Did they ever say his name? Because right now I want to go back and watch a Mucinex commercial. He's just a germ. Okay. I agree. I agree. Let's bring some awareness. All right. So we've covered Priya today, and we've covered the Mucinex guy. All right. So center is going to be 0, 0. And at this point, just start drawing the hyperbola. I'm centered at 0, 0. I'm going to make my box. Can somebody tell me how many units do I go in the X direction as I make my box? 2. 2 units. How many units do I go in the Y direction? 5. There's the box. Is everyone okay so far? Just make the box. Just look at those guys make the box. So now what I need to do is I need to determine the vertices. Are the vertices going to sit on the top and bottom or on the left and right? It all depends on what's positive. Is x squared positive or is y squared positive? Because x squared is positive, it's going to sit on the left and the right. That's how you determine it. Now, I think that everybody looked here and you looked at the bigger value, right? When I created the problem, that's why I did that. I thought that most people would be drawn to see that's the bigger value, so that, you know, because you're used to ellipses, right? For hyperbolas, it doesn't matter which value is bigger, it matters which value is positive. X squared is positive, it's going to go on the sides. Okay, I have my vertices. Name them. I need a location. Yep, plus or minus 2, 0. Excellent. What's the length of that transverse axis, the distance between the two? It's 4 units. I'm now going to draw the asymptotes. They just go through the center and then the corners of the box. So again, the box just makes everything really clean and nice and organized. Now that I have those in place, I can draw my graph. You can see how wide it is, right? It's kind of shape it makes. So I'm going to write an equation for the asymptotes. I'm going to move the foci just down a little bit. Okay, so foci. So I need a point and I need a slope. What is the point? 0, 0. And what is the slope? 5 over 2. So the equation for these asymptotes are y is equal to plus or minus 5 halves x. That's an equation for a line. It's actually 2 lines. One is positive, one's negative. Taking care of 2 lines and 1 equation. Like that, Morgan? Uh-huh, thank you. All right, what value do I have to find in order to determine the foci? C, what is the equation for C? A squared plus B squared is C squared. So does it matter which one is bigger? It doesn't, because you're adding them. So you add them together, you get 29. So we get the root of 29 is C. So C is equal to the root of 29, which is like, what, 5.5? So 1, 2, 3, 4, 5. We'll go with 6. Put a point there and a point there. So that's my foci. So I like to plot them because it reminds me that the x value changes. So the foci location is simply going to be plus or minus the root of 29, 0. I will ask on the test to express it in simplest radical form. Good? Okay, let's see what happens if we change it to vertical. So instead on the side to side, we're going to change it so they're on top and bottom. The first thing that changes is it goes like this. Y minus k, quantity squared over a squared, minus x minus h, quantity squared over b squared is equal to 1. So in this situation, now A is under Y. That really doesn't matter what A and B are. Doesn't matter what A and B are. What matters is that Y is positive. See that? Okay. So the vertices, again, as we graph this guy, we're going to put the center at HK. How many units will I move vertically from my box now? A. How many units do I move horizontally? B. So as I make my box, I go A units up, and I go B units to the left and right. So if y is positive, are the vertices could be on the top and bottom or on the side and side? Top and bottom, because y is positive. So now I put the vertices up there and down there. So as I move A units to my vertices, does that change the x value or the y value? The y value. So I have h and I have k plus or minus a. Length of the transverse axis is the distance between the two, which will be 2a. Asymptotes. I'm going to draw them. There they are. I can now draw my shape. In order to write your equation for your asymptotes, you need slope and you need a point. Notice that the point is always the center, which is hk. What's the slope in this situation? A over b. Rise this time is A, run is B. And the foci sit C units from the center. Do you think the foci sit on the side or the top and bottom? Yeah, they sit on the top and bottom because they're on the inside of the hyperbola as it opens up. So those are C units from the center. Those are my foci. And that changes the Y value. So it's going to be H and then K plus or minus C is going to be your foci. We good? Okay, let's do our last two examples. Get rid of this. We'll do that example, do one that's shifted on the other side. Okay. What do I do? Divide by 36. Good. It must be set equal to 1. So here we go. So there we go. So let's do the center. We will do the vertices, length of transverse axis, asymptotes, and foci. Is that everything? Yeah. What's the center for this guy? Yep, just 0, 0 again. There's no shift. Makes it nice. So I plot 0, 0. I make my box. How many units do I go in the x direction? 3. How about the y direction? I can't even draw my asymptotes. Okay, does this open up and down or side to side?
How do you figure that out?
Side to side. Morgan has a question. How do we figure it out? Somebody tell Morgan, how do we know it opens side to side? It's horizontal. It's the x squared is positive, right? You always look for what's positive. So x squared is positive. So again, I put that there to kind of trick you guys because I thought you would think that I would do one that opened top to bottom. It's always what's positive. Now, remember the other one opened really wide, right? This one's not going to open wide. This one's going to be narrow. So the vertices, they're located here and here. So that's at plus or minus 3, 0. So what's the length of the transverse axis? 6. the equation for the asymptotes is going to be y is equal to plus or minus, what's the slope? 2 over 3x. Good. The foci, okay, well, I'm going to give you my pet peeve right now. When I give this problem to people on the test, they just write y equals plus or minus 2/3. You guys agree that that's a horizontal line, isn't it? Like, if you put an x, then all of a sudden 2/3 is the slope. Please put the x there, otherwise I'd take a half a point off. And I feel bad doing that because I like you guys. I don't want to take points off. All right, so foci are C units from the center. What is my equation to determine C? A squared plus B squared is C squared. I love it. All right. Yes. 9 plus 4 is 13. So we got square root 13. So square root 13 is like what? 3.7 or something? So it sits on the inside there. So we got plus or minus the root of 13. 0. Cool. All right, flip it over. One more. Do you recognize the problems? They're the exact same ones from the ellipses. They just have a minus. So for the ellipses, we did this guy. We're going to do this one for the hyperbolas right now. What to do? 5 by 36. Love 36. Such a great number. Well, it's 4 times 9, right? And 4 is a perfect square, 9 is a perfect square, 36 is a perfect square. Okay. Okay. Numbers are awesome. All right. So we've got y plus 2 over 36. So y plus 2 quantity squared over 36 minus x minus 1 squared over 4 equals? Good. Now I know it's equal to 1, so now I got a valid form for a hyperbola. Okay? So this one looks like it's going to be confusing. So let's make a graph. Graphing always makes everything better. It's one of the great things about graphing. Center, vertices, length of transverse axis, asymptotes, and foci. A for the day, what's the center? Awesome, good job, you guys. 1, negative 2. You remember to grab the x value. Good job. Way to go. Okay, that's a little tricky part. You guys are smart. Okay, so what should I do? You guys tell me. Yeah, but first I should plot my point, then make my box, right? So I'm going to go over 1 and down 2. That's my center. And so how should I make my box? Six up to the sides. Okay, so I'm going to go up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And side 2. 1, 2, 1, 2. So the box doesn't sit around 0, 0. It doesn't sit centered around 0, 0. It sits centered around the center, right? Okay, so I just have to decide where to put my vertices. Do the vertices, Morgan, do the vertices go on the top and bottom or on the right and left? Morgan, do the vertices go on the top and bottom or the right and left? Top and bottom, because y is positive. Man, you're a genius. Good job. So I'm going to put them on the top and put them on the bottom. All right, so I got to name those. It's a little trickier when everything moves. So what's the x value? it's 1. And then what's the y value here? 4. And what's the y value down there? -8. Okay, cool. So what's the length of the transverse axis, the distance between them? 12. Okay, I'm going to go ahead and draw these cool thingies, asymptotes. For all those listening that are saying it's asymptotes, idiot, it's a Greek word, and I took 4 semesters of Greek, and it can be pronounced either way, and the Greeks definitely would say asymptotes, so stop it. Okay, so I drew the shape. It's top and bottom. It's really narrow, but that's the way it looks. Asymptotes, what 2 things do I need? Slope, which is? Yeah, it's 6/2, right? So plus or minus 3, and then what's the point? 1, -2. So it doesn't work to just write y equals plus or minus 3x because the center is moved. That's only if the center is 0, 0. So here's all you have to do. We're not going to put it in slope intercept form. We're just going to do this. Y minus y1, so y plus 2, equals plus or minus 3 times x minus 1. So there's an equation for 2 lines that are in point slope form. See an advantage using point slope form now? Yep. So everything has its purpose and its reason. I know you maybe didn't like it once upon a time, but we debate as a math faculty whether we should teach point slope form or not. We continue to. And anyway. All right, foci, I got to find what? C. So I do a squared plus b squared, which is, don't say c squared. 40. 40. So c is 2 roots of 10. C is equal to 2 roots of 10. So as I locate 2 roots of 10, okay, the square root of 10 is what, 3.1? So we double that, we get like 6.1, so it's going to be just on the inside there. Or 6.2, whatever. So as I move my foci, does the y value change or the x value change? The y value changes, so therefore it's going to be located at +1 and then -2 plus or minus 2 roots of 10. Not too bad. That's because you're super smart. Just think of how challenging this would be if you weren't super smart. Way to go. You're ready.